Good day everyone. So here is my output for our quarters laboratory exam regarding a circuit that defines a year, if it is a leap year or not. So first, I'm going to tackle the main logic that I use and implement in this certain task. So uh, to in, to be able to know if a year is a leap year, the first condition that should be met is if it is divisible by 4. So if a year is divisible by 4, then it has a possibility that it is a leap year. So the next condition that should be met is that it should be divisible by 4, and it can also be divisible by 100. But if it is divisible by 4 and 100, it should also be divisible by 400, because if it is only divisible by 4 and 100 and not 400, therefore it is not considered as a leap year. So if it is divisible by 100 and 400, therefore it is a leap year. So that's the main logic combination I use to determine if a year is a leap year or not. So here's the code that I use that was implemented in my Verilog HDL file to create the circuit. So first, I defined a module called leap year system. So it takes the argument input 15 and 0. That means it takes an input of a 16-bit input instead of using a BCD format for the input, since the 16-bit format is easier to make a logic with, because here we are using the natural format of the binary system. So, and then in the second argument, it outputs the leap year flag. So the leap year flag is represented by only 1 or 0. 1 represents that it is a leap year, and 0 represents that it is not a leap year. So we declare the wire for the variable divisible by 4, 100, and 400. So for the divisibility checks, for the divisible by 4, I use the logic where it only gets the last 2 bits of the 16-bit input, because as we all know, in the binary system, 4 is equivalent to 100 in binary. So if the last 2 bits of the input is 00, therefore it can be considered that it is automatically divisible by 4. So that's the logic I implemented in the divisible by 4. So for the divisible by 100, in this certain logic, we can also use that. We can also conclude that if the first 8 bits of the 16-bit input is 0000, therefore it can be considered as divisible by 100, because we can try to check it for testing, that if a 16-bit input binary have 8 zeros in the front, therefore it is a number divisible by 100. So for the divisibility by 400, I just use the logic for both 4 and 100, since the two are correlated to form the 400. So if it is divisible by 100, and if the year is divisible by 4, so that's the logic used for each of the divisibility checks. So for the final leap year logic, we use the divisible by 4 and not divisible by 100, or divisible by 400. So later in the RTL viewer, I'll show in the schematic diagram how this logic works. So I tried to test the logic if it if any errors would rise, and it was successfully compiled. So the compilation was successful with 11 warnings. So for the RTL viewer, or the schematic diagram of the uh, HDL format, um, first, here we can see from the leftmost side, the year, square bracket 15 going to 0, so that represents the input for 16-bit binary. So here we can see three circles, shape circles with equal sign inside of the circle. So each of these represents the divisibility checks that we assigned earlier in the code. So equal 0 is equal to the divisibility check for 4, equal 1 is the divisibility check for 100, and equal 2 is the divisibility check for 400. So we can see here that at the first logic gates, I use there is uh, uh, AND gates present both in the uh, first uh, first first line of the schematic diagram. So at the first AND gate, we use the output of equal 1 and equal 2 to check if it is divisible by 400. So in the second logic gate, we use not a not to this is the one represented as not divisible by 100 and divisible by 4. So as we tackled earlier, if it is divisible by 4 and not divisible by 100, therefore it uh, therefore if both of those conditions are met, then it will output 1 in the AND gate, because both of the wires are both of the wire conditions are met. So meaning there was a the AND gate recognize both 1 for the input. So 1 1 in the AND gate means the output would be 1. So the leap year plug for that was 1. So for the divisible by 400, if it is divisible by 400 or not, it will be flagged as a leap year, since in the second part we have an OR gate, that if one of the inputs in the OR gate is 1, therefore the leap year plug is equal to 1. So meaning the year inputted in the 16-bit binary is considered as a leap year. So that's how the schematic diagram works. Thank you for listening.